Good afternoon. Today, I would like to present my work on material flow analysis, or MFA, to promote circular economy development, a case study on post-industrial plastic waste in Thailand. My name is Sutha Khaodhir from the Center of Excellence on Hazardous Substance Management, and my co-workers are Dr. Ampirai Charoen and Dr. Manit Nitithanagun from the Petroleum and Petrochemical College, Chulalongkorn University. Plastic waste is one of the big problems in the country of Thailand. There are many reasons for plastic waste problems. First of all, an ineffective plastic waste separation at source. So plastic end up mixed with other waste and other plastic, both in the industry and in the household level. Plastic waste normally contain high contamination and high dirtiness level. A lot of plastic waste is multi-layer and mixed plastic waste. So both category of plastic need an extra treatment option. Overall, plastic is non-biodegradable. It usually persists in a landfill for a long time, and burning can cause environmental pollution. It's also one of the big cause of marine litter problems. This figure shows Thailand domestic consumption of selected plastic products. We can see that overall, the consumption of plastic increased since 2012 to 2018. The plastic product that has been consumed the most is bag, followed by bottles and food tray and cup box. So in order to solve plastic waste problems, we need better information on what kind of plastic and how they are collected and treated. We need new design for the system. We need a criteria to measure the progress, and we do need a good waste management scheme and technology. Today, I will talk about 3 of our research topics related to plastic waste and circular economy. Overall, in every project that I'm talking today, we utilize material flow analysis, or MFA, to study the plastic waste problems. So what is MFA? MFA is a systematic assessment of the flow and stock of the material within a system defined in space and time. So sometimes it can be referred to as the product metabolisms. We can use material flow analysis to analyze the source, the consumption, and the treatment process of each waste, in this case plastic. It can be used for sustainable resource use, to promote circular economies, and to provide an option for resource management, waste management, and also environmental management. Material flow analysis can be used in all levels, from the global society down to the individual or citizens. In few of our sample today, we have both in the country level and in the company level. So we do need a good waste management solution, especially for plastic. Plastic mainly produced from the non-renewable resources, fossil-based oil and gas, and transformed by petrochemical process. There are various types of plastic for consumption. For example, PE, PP, PS, PC, PVC, and other plastic. It has been used in various levels: industry, commercial, medical, household, and overall, most plastic is potentially recyclable. It can be recycled and can be used as a raw material for producing products. My first study today, I will talk about the post-industrial and post-consumer industrial plastic film waste survey in Bangkok and nearby province. These are the overall MFA diagram of industrial waste. So we are concentrating on the industrial part, but in this figure, we also show the commercial or consumer household part as well on the bottoms. So in general, we divided the phase of plastic use into three main phases: the plastic production, the plastic consumption, and the treatment. Okay. For industrial use, after the plastic have been used in the industry, it can be managed and can be divided into three categories. The sellable plastic, for example, PE clear film, PE mixed color films, and other films. Okay. The non-sellable and the no separation. Okay. And these are the treatment options, including recycle, fuel blending, incineration, sanitary landfill, burn to energy, and source for resale. Okay. The composition of post-industrial consumer plastic. So in general, about 30% of post-industrial consumer plastic waste is scrap. Okay. And mixed plastic and packaging account for about 10% each. Film is a small part of the plastic waste, account altogether probably 10 to 20%. So we can see that this number, okay, showing you the amount of plastic waste from the industry. In Thailand, if you are an industry, you are required to register your waste by the 6-digit number. So after we sourced the data, we found that of all the industrial in Thailand, there are 4 main waste that code that are plastic, and from those codes we get the total amount of the plastic that have been registered into the system. We can see that film normally account to about 10 to 20% of the total plastic waste. Okay. This figure on the bottom left show you the total amount of plastic in ton per year at Bangkok and the nearby province. Okay. So in general, plastic is collected and recycled in many ways. We can see that more than 65% of plastic has been collected and resale, and about 60% go to recycle factory. And other than that, most of them go to fuel burning, incineration, and only a small amount going through landfill. However, if we look carefully, and this is why we more concentrate on film plastic, because film is very light, very small in weight, and it's the one that you normally find it end up in the landfill. Okay, so this figure shows you that the type of plastic film waste and their treatment method. Okay, the total film waste, which about 20% of all the plastic waste from industry, altogether is about 36,000 tons per year. This is collected from 700 sites in Bangkok and 5 areas. Okay. And it includes bag, label, snack bag, wrap, bubble sheet, and films. So these are the treatment options that have been registered in the database of the Department of Industrial Work. We can see that film, label, and plastic tape snack bag, these have a big portion that end up in the landfill. So even though we can see that overall plastic has been collected, resale and recycled, or the least it has been blended into as a fuel blended. There's still some plastic, especially film plastic, that end up in the landfill. Okay. The second study that I like to mention is the other part of that study, which now we concentrate more on the household part. But however, for the household part, we only concentrate on PP and PE plastic. And for household, we can divide it that from the production, consumption, and waste generation. We divided plastic, PP and PE into two groups, food and the non-food plastic. Okay. So most of plastic going to recycle, some of them go to landfill, and then there are some of the pieces from the household that have been missing from the system. These are the numbers that we can calculate from our study. So from the school, hotel, shopping mall, coffee shop, bakery and restaurant, and apartment and condominium, both for HDPE and PP. The last study that I like to mention in today's talk is our ongoing project on the estimation of municipal solid waste generation using material flow analysis. In this study, we want to revise the number of solid waste generation, the percentage of recyclable materials, including glass, paper, plastic, metals, aluminum, and food in Thailand. Okay. So we again using material flow analysis as our framework to set up the boundary of our study from the production phase to the consumption phase and to the treatment phase. Okay. So we would like to do it from the left to the right and also from the right back to the left to cross-check the number. I explain it later. So when I say from the left to the right, we want to know how many products that we are using in the household or in the industry and how long that we keep them with us. What is the service life of each product? And then we try to estimate the waste that will come in the future. Okay. So for plastic, okay, we selected 12 target products in this figure. And for plastic, we only have service life of short life and medium life. Okay. So we try to estimate how long that we use all these products and how many of them that we use during a period of time and how long that it will become a waste and how much waste that become at a certain time. And what are the category of waste management that we are doing at the moment. Okay. On the other hand, that I say that we want to also cross-check by working back from the waste management back to the consumption part. So we go to the waste treatment facility, landfill transfer station, incineration, and collect solid waste sample and try to analyze for its composition, especially plastic. As I mentioned earlier, you can see that even though plastic in the big picture has been recycled effectively, most of the plastic film, especially bag and package, end up in the landfill. So this is what we found at the disposal site. Okay. In this study, we target to sample in every part of a country. Okay. At the moment, we finished 2 big municipal areas, including Phuket in the south and Chiang Mai in the north. And this is our initial result. We found that most of the waste at the disposal site, 40% of them is food waste, and plastic still contain about 20%. Okay. And for plastic, so the bigger part of plastic waste still bag, followed by bottles. Normally, bottles has been collect separate and resell, but the bottle that end up at the disposal site normally is dirty bottle. Okay. So these are the waste composition. You can see that these are all the plastic that has is the problem at the moment. The bag, the film plastic, as well as the multi-layer plastic. Okay, so overall, I think the study can show you that in Thailand, as in many countries, we are doing quite well in terms of percentage of recycled plastic, but there are still some category of plastic that still have a problem and end up at the disposal site. In this case, films and plastic bag. So we think that MFA can be used to help us see the critical view of waste management, evaluate the option, environmental soundness waste management option, and it can also help promote the circular economy. Okay. I would like to thank my sponsors and my partners of this research. First of all, the Center of Excellence on Hazardous Substance Management, the Petroleum and Petrochemical College, Chulalongkorn University, the Suez Service Company Limited, and the National Research Council of Thailand. Thank you very much.